Role of the ozone layer. The ozone layer acts as Earth's natural sunscreen, absorbing and filtering out most of the sun's harmful ultraviolet UV radiation, particularly UVB and UVC rays. UV radiation can cause various health problems in humans and other organisms, including skin cancer, cataracts, and immune system suppression. Additionally, UV radiation can harm marine ecosystems, damage crops, and degrade materials such as plastics and rubber. 2. Chemistry of ozone depletion. Ozone depletion refers to the gradual decline in the concentration of ozone molecules in the ozone layer, particularly over the polar regions. The primary cause of ozone depletion is the release of human-made chemicals known as ozone-depleting substances, ODS, including chlorofluorocarbons, CESFCs, halons, carbon tetrachloride, and methyl chloroform. When these chemicals are released into the atmosphere, they undergo chemical reactions that release chlorine and bromine atoms. These chlorine and bromine atoms catalytically destroy ozone molecules in the stratosphere by breaking them apart. O3 plus Cl, O2 plus Cl, OClO plus O, O2 plus Cel. The net result of these reactions is the reduction of ozone molecules and the thinning of the ozone layer, leading to the formation of the ozone hole, particularly over Antarctica. 3. International efforts to address ozone depletion. The recognition of the ozone layer's importance and the threat of ozone depletion led to international efforts to address the issue. The most significant of these efforts is the Montreal Protocol on Substances that Deplete the Ozone Layer, which was signed in 1987 and entered into force in 1989. The Montreal Protocol is an international treaty designed to phase out the production and use of ozone-depleting substances. Key provisions of the Montreal Protocol include phasing out the production and consumption of ODS, including CFCs, halons, and other ozone-depleting chemicals. Establishing control measures and timetables for the reduction and elimination of ODS. Providing financial and technological assistance to developing countries to support their transition to ozone-friendly alternatives. Implementing monitoring, reporting, and compliance mechanisms to track progress and ensure adherence to the treaty's requirements. The Montreal Protocol has been hailed as one of the most successful environmental agreements, with widespread international cooperation and significant reductions in ODS production and consumption. As a result of the Montreal Protocol and subsequent amendments and adjustments, the ozone layer is gradually recovering, and the ozone hole is showing signs of stabilization and healing. 4. Stratospheric ozone. Formation. Ozone molecules in the stratosphere are formed naturally through the Chapman cycle, which involves the interaction of oxygen, O2 molecules with ultraviolet, UV, radiation from the sun. UV radiation with wavelengths shorter than 242 nanometers, nm, dissociates oxygen molecules into two oxygen atoms, 2 plus, 2O, 2 plus UV2O. These oxygen atoms can then react with other oxygen molecules to form ozone, 2 plus, 3O2, so O3. The formation of ozone is balanced by its destruction through natural processes, maintaining a relatively stable concentration of ozone in the stratosphere under normal conditions. 5. Ozone depletion mechanisms. In addition to human-made ozone-depleting substances, ODS, natural processes and phenomena can also contribute to ozone depletion. For example, polar stratospheric clouds, PSCs, in the polar regions provide surfaces for chemical reactions involving ODS, accelerating ozone depletion during polar spring. Furthermore, volcanic eruptions can inject sulfur dioxide, SO2, into the stratosphere, leading to the formation of sulfate aerosols that enhance ozone destruction. 6. Effects of ozone. Depletion. Ozone depletion can have far-reaching consequences for human health, ecosystems, and the environment. Increased UV radiation reaching the Earth's surface due to ozone depletion can lead to higher rates of skin cancer, cataracts, and other health problems in humans. UV radiation can also harm marine life, including phytoplankton, corals, and fish larvae, affecting marine ecosystems and biodiversity. Additionally, UV radiation can degrade materials such as plastics, rubber, and paints, impacting infrastructure and materials used in construction and transportation. 7. Ozone hole. The term ozone hole refers to the severe depletion of ozone concentrations observed over Antarctica during the Southern Hemisphere's spring, September to November. The formation of the Antarctic ozone hole is attributed to a combination of factors, including the presence of polar stratospheric clouds, PSCs, and the release of ozone-depleting substances, ODS. The ozone hole represents a localized and temporary reduction in ozone levels, but serves as a stark reminder of the global impact of ozone depletion. 8. Continued monitoring and research. Despite significant progress in addressing ozone depletion, continued monitoring and research are essential to understand the dynamics of the ozone layer and atmospheric chemistry. Ongoing satellite observations, ground-based measurements, and atmospheric modeling efforts provide valuable insights into ozone depletion trends, atmospheric composition, and climate change interactions. Long-term monitoring and research efforts contribute to informed policy decisions, public awareness, and international cooperation in safeguarding the ozone layer and mitigating environmental risks. Thank you for watching. Please subscribe for more.